Good morning, my algebros. So before we take the quiz, I want to go ahead and give you this warm-up to remind you of how to do our things that will be on the quiz. Go ahead and take about 2 minutes and do this warm-up. If you're online and watching this video, go ahead and write these down, pause the video, and then we'll go over it. Okay, on number 1, anything to the 0 power is 1, so the answer is 1. On number 2, Y needs to take the ticket. And number 3, A takes the ticket, B becomes 1, and C takes the ticket. Then I go ahead and evaluate that, where I have C squared, which is 8. 8 squared is 64, and A is 2, and 2 to the 3rd power is 8. And 64 divided by 8, well, that's just 8. All right, we're going to take a quiz, and then we'll get to today's rational expressions. Rational exponents. Okay, rational exponents. What does that mean? Well, a rational is just a fraction, right? So let's first talk about roots. You guys are used to roots. We've been doing all of these exponents, so the opposite of having an exponent, like something to the 2nd power, would be a square root, right? Normally used to this root bar, and we don't put a 2 there because we know it's a square root. But did you know that there can be more roots than that? So that little part where we have that 2 is called the index. And we say that because you can have more than just a square root. For example, we know that the square root of 25 is 5 because the number that would be multiplied twice to itself is 5. 5 times 5 is 25, or the square root of 25 is 5. But we can also have other roots. Like if I had a 3 there, this would be called the 3rd root. And you guessed it, it would be the number that is multiplied by itself 3 times to be that number. For example, if I have the 3rd root of 125, that is also 5, because 5 times 5 times 5, or 5 to the 3rd power, is 125. So let's talk about our fractional exponents for a moment here. We know that B is the base, and the top part of the fraction is the exponent, and the bottom part of the fraction is the root. My son and I like to call these BER, because it's base, exponent, root. I say BER, they give me the chills, like BER, base, exponent, root. It reminds me which comes first and which comes second. He likes to say that fractional exponents send him to the ER, so he remembers the exponents at the top and the roots on the bottom because he remembers it as going to the ER. So again, if I were going to solve 16 to the 3 over 2 root, I know that the root is the 2nd or square root, and the square root of 16 is 4. And then it's to the 3rd power, and 4 to the 3rd power is 64. So you do what's inside the parentheses first before you do the outside. So let's take a few of these examples and go ahead and simplify. So if I have 125 to the 1/3 exponent, I know that the exponent's going to be 1, or just to the 3rd power. So what we're only doing here is really just getting the 3rd root, which we know is 5. If you're in class, I'll be showing you how to use the calculator correctly. So if 64 to the 6th root, because the exponent's just 1. So I know that's going to be 2, because 2 to the 6th power is 64. Go ahead and do this. You try, pause the video, and see how you did. So hopefully you figured this out. It just means this is the square root of 121, which is 11, because 11 times 11 is 121. So again, we're looking at fractional exponents. And I like to say BER because it reminds me that it's BER. But my son likes to say, oh, this sends me to the ER. So we have base goes inside the base, and the root goes in the index, and the exponent goes on the outside. And using PEMDAS, we solve what's inside the parentheses first, and then we do outside. So let's do a few of these together. So I have 216 to the 2/3 power, which means that 216 goes inside, it is the base. My root is 3, and my exponent is 2. So first I set it up. Then I take care of inside the parentheses. And the third root of 216 is 6. And then 6 squared is 36. Let's look at another one. So our first step is to set it up, remembering that it's ER or BR. We deal with our base first, then we set up our root and our exponent. We take care of inside the parentheses first. The fifth root of 32 is 2, and then we do it to the exponent of the fourth power, which is 16. So this means that we can also add up these things. So if I have 81 to the 1/2 power plus 27 to the 2/3 power, what would that be? Well, first I need to simplify them. So I know that the square root of 81 is 9. And the third root of 27 to the second power, well, that's also 9. So the answer to this is going to be 18. Go ahead and try these, pause the video here, and then check your work. So number 1, we have first setting up, our base goes inside, is to the fourth root to the third power. The fourth root of 16 is 2. 2 to the third power is 8. On number 2, we first have to evaluate or simplify. So we get 8, the third root of 8 is 2. And 2 to the second power is 4. And then this square root of 4 is 2. So then 4 plus 2 is 6. All right, now how do we do it the other way around? What if we have these? What if I have exponents inside my base? Well, there's a little bit of a shortcut, but I'm going to show you 3 ways to think about this. First, let's take a look at this. We know that if we put it back into fractional exponents, we know that this is to x to the 9th, y to the 3rd to the 1/3 power, right? And if we know that, then we could go back and use our exponent rules and distribute. And then we're just multiplying fractions, and we reduce those fractions to get the answer, right? That is one way to do this. We can also just break it down. What exactly is inside of this root bar? Well, we have 9 x's and 3 y's, and we're grouping them in groups of 3. And if we do that, we have x to the 3rd times y, the same answer we got before. Here's my preferred method. I just know that if I have a fractional exponent, I could move them into a fractional exponent, but because it's to the 3rd power, I know, and that there's no exponents on the outside here, I could just divide by 3. And this is my shortcut. Let's look at this again. If I have a to the 8th, b to the 12th in the root to the 4th root, I can just divide by 4. Much simpler, right? The only problem that happens if something doesn't divide evenly, then you have to do it another way. But we know we could just leave them as a fractional exponent too. Now what happens if I have one of these divided by something else? Well, that's okay. First steps first. I first take care of the top by dividing by 3. 15 divided by 3 is 3. 15 divided by 5 is 3. And y to the 20th divided by 5 is 4. Then I move over the fraction, and I'm just doing exponent rules again. I know with exponent rules, I just subtract, right? So I'll get x to the 0 power, which is 1. So my final answer is just y squared. So again, take care of the top first. This is square rooted, so I just divide everything by 2. And then I move over the bottom of the fraction and use my exponent rules and subtract. And get 3 minus 2 is 1, so it's just a. And then b to the 4th minus 1 is just b to the 3rd, and no tickets to take. Go ahead and try these. I know they're not hard, but there's a lot of steps. So good notes are really important. Let's see how you did. On number 1, we're just dividing by 3. On number 2, we have to first divide by 7, and then we have to resolve the rest of our fraction here. Okay. The warm-up that we did was scientific notation, and the homework today is going to be the textbook problems 1 through 30.